Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading and helping you out. This is the 14th video guys, and please do expect a total number of 33 questions. Organic chemistry guys, it's a huge part of your examination. It contributes about 50 marks, so that's a lot of marks guys, and hence it is divided into three parts. Right now we are focusing on the intermolecular forces and the factors which are being affected by intermolecular forces. However, in all the 33 videos that I will upload in here on YouTube, please note that I will cover all three sections of organic chemistry. It's very important for you guys to understand how to tackle these exam questions. Okay, let's start. First question, we are being asked to define the term boiling point. Boiling point is just the temperature at which the vapor pressure of a substance equals to the atmospheric pressure. Okay, and then 3.2, what is the relationship between the strength of intermolecular forces and boiling point? Please note that the stronger the intermolecular forces, the higher the boiling point, and the weaker the intermolecular forces, the lower the boiling point. So the relationship between the two, they have direct proportionality. Okay, the relationship between strength of intermolecular forces and boiling point is investigated using four organic compounds from different homologous series. The compounds and their boiling points are given in the table below. Okay, we have compound A. Compound A is an alkane, and the types of intermolecular forces that exist in alkanes, they are called London forces, the weak van der Waals forces. And then we also have propan-2-one. Propan-2-one is a ketone. The type of forces that exist within a ketone, they are called dipole-dipole forces. And then compound C, it's propan-1-ol. It's a primary alcohol. And in primary alcohol we have a hydrogen bond, which is the strongest. All together. Also we have propanoic acid. Propanoic acid is a carboxylic acid. It has two sides of hydrogen bonds, and hence carboxylic acids will be stronger than alcohols. Let me just write two sides of hydrogen bond. Okay, 3.3, we are being told to refer to the type and strength of intermolecular forces to explain the difference in boiling point between compounds A and B. Okay, compound A and B. This is how guys we should answer these questions, né? Let's go. Compound A. Compound A has London forces, and compound B has a dipole forces. And then secondly, since dipole is stronger than London forces, we'll therefore conclude that compound B has stronger intermolecular forces, and hence more energy will be required to separate the bonds in compound B, and hence compound B has a greater boiling point. Hence compound B has a higher boiling point. Whenever guys you compare two molecules, you must first talk about the difference. Here the difference was the type of intermolecular forces that exist between these molecules. Secondly, do state which compound between the two has stronger intermolecular forces, and then you'll talk about the energy. After talking about energy, you'll therefore conclude based on the question. In this question, we are investigating about boiling point. So the last point will have to be about the boiling point. Are we together? If you wanted to make conclusions between compound A and B by just focusing on compound A, yes, the first point will be the same. Compound A has London forces and compound B has dipole forces, and then on this point we'll therefore say compound A will have weaker intermolecular forces compared to compound B, and then on the third point we'll simply say that less energy will be required to separate the bonds of compound A compared to compound B, and then hence the boiling point of compound A is lower than that of compound B. You can contrast by using the two compounds. Are you together? You need to choose which compound are you taking as a reference. I chose B as my reference. You can choose A as well. Okay, now let's go to 3.2. We are comparing compound C and D. Compound C and D. Okay, compound C and D, both compounds have hydrogen bond, which is the strongest, However, okay, let me first state that both compounds has hydrogen bond. However, compound D has two sides of hydrogen bond. Please note that, guys, any carboxylic acid has two sides of hydrogen bonds. Any carboxylic acid. Are you together? Okay. So since compound D has two sides of hydrogen bond, it simply means that compound D has stronger intermolecular forces. Intermolecular forces, and then more energy will be required to separate the bonds of compound D, and hence compound D has higher boiling point. Are you together, guys? Answering these questions, guys, it's the same. First point, you must state the difference between the molecules. Second point, states which one has stronger intermolecular forces. Third point, talk about the energy that is required to separate the bonds. And then thirdly, you just need to conclude. Are you together? Okay, so if we wanted to contrast, okay, over here guys, I contrasted between the two compounds by just focusing on compound D. Compound D was my reference. Are you together? But if I wanted to make compound C my reference, I would have said that yes, both compounds have hydrogen bonds. However, compound C has only one site of hydrogen bond. Are we together? And then the second point would have been compound C will have weaker intermolecular forces compared to compound D. And then the third point would be less energy will be required to separate the bonds of compound C, and hence compound C has the lower boiling point compared to compound D. That's how guys you could have answered these questions. Okay, is compound B a gas or a liquid at room temperature? Propanone. Propanone is a liquid at room temperature. Propanone is a liquid at room temperature. Okay guys, I really hope that guys the videos helped you out, and just stay tuned and wait for more.